Using this laptop's mobile hotspot, we connected the two Raspberry Pis, the sender and the receiver node, in one network. So this is the network that we will use to provide the connection between the two Raspberry Pis. Finally, we have set up the sender and receiver part of the Raspberry Pis. This is, as you can see, this is the sender part and this is the receiver part. So this Raspberry Pi has the receiver code running on it, and this Raspberry Pi has a sender code running on it. They're sharing the information using UDP protocol. And because the sender has the sender code, that hence it has the webcam. Now, what we do is we start the sender so that it starts, and then we start the receiver so that it starts. So we can see that the stream has started. And now if we show, Rishi, can you just show this? So if we show a red dot to the screens, and then you can see on the receiver side, it can tell you the directions of where it is moving, and it also tell you the area of the circle that has been detected. And on the sender side, it is sending the data back. As you can see, all of the logs have been sent back to the sender, and over on the receiver side we will see the area and all the dot calculations, and everything is working as expected. So this is the sender and receiver setup that we made. Hi all, welcome to this demo of the dot tracker system that we have built using OpenCV and other libraries. This is the screen view. Let me explain to you the interface. On the left hand side we have the receiver node, that is the PC, and on the right hand side we have the remote Raspberry Pi. I am streaming the screen of the Raspberry Pi on my MacBook so that I can record the MacBook screen and the Raspberry Pi screen simultaneously on one screen together, so that I can show the demo, so that we can show the data exchange between the two nodes in our network that we have created using zero tier console. I would like to show you the console. This is what the zero tier console looks like. So as you can see, this is my Pi, and then this is my PC's IP address, virtual IP address. This is properly a virtual private network that we have created, and different my friend's Raspberry Pi has been also been attached, so that we can demo the red dot tracker system on two Raspberry Pis, which one will be the receiver and one will be the sender. Now we are going to see that how the stream gets started from the sender side, that is the remote Raspberry Pi side, and we will see the stream being rendered on the MacBook, that is our receiver. So once I put in the command to start a receiver server, we can see the receiver server is listening on 172.30.163.155. And on the Raspberry Pi side, if I start the sender, then it will start sending the frames. So once I click on this, so you can see that the video transmission has started. The right hand side is on the Raspberry Pi, and there is a lag because it is being streamed using the VNC server on the MacBook, and using one other socket we are streaming the live stream of that video as well. So you can see the live stream is faster, but the VNC server stream is a little slower. So you can also see that right now the red dot detected area is 0, and there is nothing being displayed on the processed video. So there are no directions, there is no red dot, because there is no red dot in the video frames that are being processed. So what will happen is I'll show a red dot to this screen, and as soon as I show the red dot, this area will also increase because there'll actually be a red dot. So let me just show you. So if I show the screen a red dot, so you can see now the area has also started increasing by the order of thousands. We can see as we bring the dot closer and closer to the screen, the size increases. So does the area. As we take it far, the area decreases. I'm talking about these numbers. Oh, I'm sorry, that feed went off. My mistake. I brought it back. So You can see it also tells us about the direction where the dot is traveling. So it is going right, it is going left. If I take it up a little, if I take it down a little, it works that ways also. So this is the right, this is the left. As you can see, this is a proper red dot tracker system. You can see the green line that has been formed to, enclose the red dot. If I twist it a little, you will be able to see it with a better perspective. So you can see that the green line is showing the position of the dot. If it is properly aligned to the screen, then you will see that it has completely enclosed the green dot. So it is accurately working. Also, we can see on the Raspberry Pi side that there is no annotations, there is no directions, or there is no green line appearing on the dot. That means that is the sender side of the system. It is sending the frames which are being processed on the receiver side, and the annotation data has been added to that, and the processing is going on in that fashion. Welcome to the last iteration of the system demo. In this, we are going to use a remote Raspberry Pi and a multi-access Edge Linux instance that has been deployed using mastcompute.com. This is a website that I found using research tools and Google and AI tools, which suggested that this is a website that provides access to Ubuntu GUI environments. So basically, there's not only a terminal, you'll get a proper desktop which will have all the graphical libraries and drivers that we need to run our video streaming project that is related to red dot tracking. So next we will see how we can set up this Edge Linux instance to become the receiver part of our system, and then the remote Raspberry Pi will stream the webcam data, the webcam frames, to this Edge Linux instance. And on this online server that is hosted in the cloud, we will see the processing happening, and we will see how we will be popped up with the real live stream from that remote Raspberry Pi with all the annotations and the tracking operations that we fixed on the receiver code that we just saw with the PC and the remote Raspberry Pi setup. Now, first the step is to go and log in and create an account. I have already done that, and we can choose between different type of images. So this is a creator images. They give some pre-installed libraries to creators. For example, someone wants to use AI or something like that, so they'll give that kind of libraries. We can choose any kind of image. So I'm choosing base image. Base image, see, you can see use Ubuntu desktop, and it will give you access to a proper Ubuntu desktop with all of the GUI libraries that you need for this project. And we'll click on deploy, and you have to be careful. These are all the different type of hardware that the Linux instance will use to run your system, to host your system and your red dot tracking system basically. So what I'll do is I'll select a good GPU. So let's go for this one, which gives 256 GB RAM. Let's go for this one should be enough, more than enough. And we are choosing the base image, Ubuntu desktop 22.04 version, GPU quantity 2, and we click on deploy, and now it will go and deploy our Ubuntu Linux instance on the cloud for next to nothing. This initialization part takes some time. So on the right hand side we have the remote Raspberry Pi, and on the left hand side we have our multi-access Edge Linux instance running in the cloud using mastcompute.com. Once we initialize this instance, then we will see how we will run the code and create the synchronization between these two nodes. So now we can see that the Linux cloud instance is running on mastcompute.com. Now if we click this icon, we will see the login details. We will see a link that will also give us the IP address of the Linux instance that has been hosted online, the username that will be used to access it, and the password. So once I click on this, it will prompt this, but it's just some networking configuration thing. It's not really unsecure. So I'll use the username and password that was given to me on the mastcompute.com console to log in into the server, and then it will take me to the desktop environment. As you can see, the process has started. We started, and we are in. So now you can see that we have arrived on the Linux Edge instance desktop, a proper GUI environment for you to use, and as a part of the receiver, as a receiver part of the system. Now, before actually running the code, we will have to make some configurations and some installations so that it recognizes the files that we are trying to run. For example, right now, if you try to even find Python, it is not there because Python is not installed on the newly created instance of Linux, Ubuntu Linux. So over here, I have a file installation that I have created, initial set of commands that we need to run on the instance. So using the SCP protocol, I will send the initial set of instructions onto the Linux instance. Once I click on enter, it will ask for authentication. Once I click on, so it will ask for the password of the instance. So the password of the instance is this. We'll copy this and we'll simply go and we'll paste it and we'll enter, and voila, you have just sent the file on the desktop. Home folder has been created. We go there, we cancel this and multi-access. We have this file over here now. Now we can begin with the initialization of our cloud instance. We copy this and we paste it over here so that the sudo app upgrade command can run. Now before trying to install OpenCV, because what I believe is this might be already installed, what we should do is we should send the receiver part, the receiver file, our receiver file that we are supposed to run on the Raspberry Pi in the first iteration, on the MacBook PC on the second iteration, on the third iteration we are running the same receiver on the Linux cloud instance. So what we'll do is, using simple copy protocol again, we will send this file to the Ubuntu desktop first. So receiver.py, I just enter the receiver.py, I enter the username, I enter the IP address, I enter the destination folder, and I say click enter. It will ask for the password. I go over here and I copy the password, then I come over here, I paste the password, I enter. So you can see that the receiver.py has been transferred, and over here also we can check that indeed we have a receiver.py now in this cloud instance. So we can see that we can communicate with this instance so easily using proper networking and IP addressing and everything. So now we open the terminal and we try to run this file. So are we on the desktop? No, we are not. Desktop, ls, and we have that. So now we try to run this Python receiver and let's see what kind of errors do we get. So Python 3, let's try Python 3, because we did just install Python 3. So no module named CV3, so we need to install this also, Python 3 OpenCV, because this library is required. So this is how we go about the installation process, and now you can see that the OpenCV package is about to be installed. So now that has installed. Now if we try to run the Python receiver again, so it says cannot assign to the requested IP address. That makes sense because we have not yet changed the receiver IP address in the receiver file that we need to. But before doing that, what we need to do is connect this Linux cloud instance into our own VPN that we created using Zero Tier. So that is a very important step, because if this node is not in our network, then it will not be able to stream from anywhere in the world. It needs to be inside of our virtual private network to stream securely. So what we are going to do is install Zero Tier on this node again. It should be very fast and easy. should not take that much time. So we'll install zero tier on this node and join our zero tier network that we created using zero tier console. As you can see, all of the nodes are present over here of the Raspberry Pis that we used, of the PCs that we used, and of the Linux cloud instances that we will use. So now you can see that we have installed zero tier, and it also assigns an address to the node. Now this is the unique ID of my network using which I can join that network. So once I do this, you can see it has joined that network. And now if I go in the console, you will see that there will be one more node which will be assigned a virtual IP address, my friends. So you can see that this is the new node. I authorize it and I name it as multi-access Linux Edge instance, and this completes, why was it not named multi-access Linux? So we save it, and then we can see that name has been popped and that it has been assigned a IP address. Now this is the IP address that we are supposed to use in our demo. So let me just remember that. So it is 30.38.143, 30.38.143. So 30.38.143 is the IP address that we are supposed to use. So what we will do is we'll just close this initialization files as we no longer need it. We'll go over here. This is the receiver code that we transferred to our node using the simple copy protocol, and over here we will find a place where we need to set up the receiver's IP address. So this needs to be 172.30.28. Is it 28 or 38? 38. That was wrong. 38.143. So once we set this 143, so once we set this receiver as the IP address that our zero tier network assigned to this Linux cloud instance, so the network is also on the cloud and the node is also on the cloud. I must appreciate the technology and the power that this thing has. So once we did that, so now I've cleared the console, and now if I run this, so you can see the server has started listening on the zero tier assigned IP address at this port. Now on the remote Raspberry Pi, which is running on the right hand side, as you can see the screen, we will again change the IP address from this to where our receiver is running, as you may see where our receiver is running. So 1738.38 .143 is the address, and once I run that, and so server is listening, and once I run the sender, so you will see that from the remote Raspberry Pi, which is the client, which is the sender, which has the webcam connected to it and is sending the webcam to this cloud instance, which is acting as a receiver, will show you the video with complete annotations and directions, just like we saw in the case of the PC and the Raspberry Pi to Raspberry Pi connection. I'll show it this dot, and you will see the magic happen. So I run this, and you can see that run sender.py, and it has started sending the data, and this node has started receiving the data. So you can see that this node has started receiving the data. As you can see that the internet connection, it will be a little bit slow because you have to understand what is happening right now inside of the web browser. So on a web browser, we have hosted a computer, basically a Linux computer, and on that Linux computer we have connected a Linux computer to our own network, and on our own network we are transferring data from a Raspberry Pi to a cloud hosted Linux instance, multi-access Edge Linux instance. So this is the amount of work that is going on right now, and just to show you how it might, if it fits in the screen, then I will be able to show you better. So let me just make this. So this is the Edge Linux instance, and on the right hand side we have the Raspberry Pi running as well. Now once I show it this, so you can see on the Linux Edge instance also using cloud computing, and everything is deployed and hosted online and running inside of a browser. This video streaming and processing is working just fine. Left, it can tell you directions, and there is the proper green line that is enclosing the contour of red. So this is the final part of the demo where I show how we used a remote Raspberry Pi and a multi-access Edge Linux instance to video stream data between the two nodes. This is how it works. This is my system. I have done all the iterations as asked for. Thank you so much. If you have any doubts or anything like that, or if you have any suggestions or appreciations, please use the comment section. Thank you so much.